Now, as an example on mutual inductance, we have seen in this figure two circular closed back coils. The smaller one with radius R2 and it has N2 turns, and this smaller one is coaxial. Coaxial means that it has the same center with the larger radius R1 with N1. So we have larger coil with R1 and N1 turns and in the same plane. So they have the same value of the height. It is required to derive an expression for the mutual inductance M for this arrangement of these two coils, assuming that R1 is much greater than R2. Alright, how to start? First of all, assume that we are going to start from coil 1. We want to find out the magnetic field B1 due to the current I1. And then this B1, we will find what will be linked by the coil 2. So the linked flux by coil 2 in this case would be B1 multiplied by the area of the second coil. And by dividing the linked flux by coil 2 multiplied by its turns number N2 over the current in the coil 1, we can find out the mutual inductance between these two coils. So this is our plan. Let us start. We say that the mutual inductance would be the linked flux by the coil 2, which is N2 multiplied by phi 21 over the current at the first coil I1. So phi 21 equals the magnetic field induced by the coil 1, B1, multiplied by the area of the coil 2, A2. The area of the coil 2 can be obtained as pi R2 squared. So this is the area A2. The question now is how to determine B1. If we have N1 turns and N1 turns having a current I, we can find the magnetic field by using Biot-Savart law as mu naught I R squared over 2R squared plus Z squared to the power 3 over 2. This was the magnetic field of a coil. So in the present case, the value of Z, where we measure the magnetic field, equals 0 because they are in the same plane. So the magnetic field due to a coil would be mu naught I R squared over 2R to the power 3. So it is mu naught I over 2R. Okay. Now we apply this for R1 and we have N1 turns. So the magnetic field due to the first coil is N1 multiplied by mu naught I1 over 2R1. So this is B1. Now we have B1 and we have the area. So the flux linkage N2 multiplied by phi 21. So it is N2 multiplied by B1 multiplied by area 2. So we collect these pieces together to find out N2 phi 21 would be N2 multiplied by N1 multiplied by mu naught multiplied by I over 2R1 multiplied by the area 2 by multiplied by R2 squared. So this is the flux linkage from coil 1 to coil 2. Now, by using this flux linkage from coil 1 to coil 2 over the current I1, we can find out the mutual inductance. So the mutual inductance is N2 phi 21 over I1. So by dividing this one by I1, so I1 here will go with this I1, so it will disappear. So in this case, the mutual inductance is mu naught by N1 N2 R2 squared over 2R1. So this is a mutual inductance between these two sets of coils. Okay, alright.